Okay, so on this question, they're giving us a situation. This is actually called scientific notation. We'll talk more about it on some other problems, but we're basically wanting to write this, do something about this 10 to the minus 4. What does that 10 to the minus 4 do? Well, basically, it means move the decimal 4 places left. That's what it means. So in other words, you take this number 4.16, and then you're supposed to move the decimal 4 places left. Ready? 1, and you're to the edge of the number. 2, 3, 4. So that's going to bring in zeros, and the decimal ends up right there. Does that make sense what just happened? So it ends up becoming 0.000416, and that's the answer to the question, 0.00416. So what did I just do? I moved the decimal 4 places left. That's what that 10 to the minus 4 tells you to do with this 4.16. It says take that decimal from where it's currently sitting and move it 4 places to the left. 1, 2, 3, 4, like that. Now, if that power had become positive, in fact, let me show you one where it is positive. That would be the very next one. Here, I'll grab this one. Put it in there next to the other one. And let's put it right over here. Yeah, squeeze it in over here. Okay, so on this one then, now we got a positive 5 power. Notice, positive 5 power on the 10. On the 10 means move the decimal 5 places to the right. So do you see the deal? When the power is negative, we move the decimal to the left. When the power is positive, we move it to the right. Now, I'm going to give you a reason why this is true in just a second. Let's just first off do it. So I take the 3.13, and I'm going to go 5 places to the right. Well, how do you do that? How do you do 5 places to the right? Well, you go once, twice, and you're to the edge of the number. 3, 4, 5. They're going to bring in zeros. Whenever you go beyond the edge, you bring in zeros. So the decimal ends up right there. So it's 313,000, decimal right there. So that's your answer. 313,000. You can put the decimal. You don't have to put the decimal. You might say, what do you mean you don't have to put the decimal? You know that, right? That's not something new. What do I mean? I'll say the price on that new fish tank is $27. So we said, oh, what do you mean? I thought it was 27.00. Well, that's the same thing. We all know that, huh? We all know that if you don't put the decimal at the end, it's the same thing as it really being there. We know those are the same. So that's why I say this decimal here, put it this way, this decimal here, this decimal is option, right? When there's a decimal at the end of a number, like $27 or just write it that way, it's the same meaning either way, whether you show it or not. So what I'm saying is you could leave it off, and that's fine too, right? If there's no decimal showing, it means it's at the end. We know that. Think about your common experience with prices. $27, you know that means 27.00, right? So that decimal at the end, you can put it there or leave it off. Either way, same thing, it's optional. So what happened then? Let's be clear on this. If you have times 10 to a negative power, negative means move it to the left that many places. So it was started right here between the 4 and the 1. That's how they originally gave it to me. I got to move it 4 places to the left. Well, the first jump, it gets to the edge. And once you go beyond the edge, left or right, you bring in zeros. So the next 3 jumps, or 4 jumps total, bring in zeros. So 0.30,416. Now on this one, it's 10 to the positive 5. Positive means move to the right. Decimal starts out between the 3 and the 1. I move 1, 2 to the right, and I'm at the edge. And when you go beyond the edge, you always bring in zeros. 3, 4, 5. Total jumps to the right, brings in 3 zeros, and you can put the decimal or leave it off. It's optional. We know it means the same thing either way. Decimal at the end, you can show it or skip it. So now why does it do that? So that's the rule. That's what that's a 10 to a power. That's whenever you take a decimal number and you multiply by 10 to some power, that power moves the decimal. If it's positive, it moves it to the right. If that power is negative, it moves the decimal to the left. Now, why? Why does it do that? Well, I think you know that already, right? Take a price like $2.73. Well, so yeah, I bought something that was $2 and let's just say 70. I bought something that was $2.70, and I bought 10 of them. So $2.70. I bought 10 of these little sodas that are $2.70 each. So what's the total price I'm going to pay for that? Well, you know it's just going to move the decimal. It's going to become $27, isn't it, right? You know that when you multiply by 10, the effect is it moves. Well, what just happened there? Well, that's really a 10 to the 1. But I said, no, let's try it again. I said, no, I know I'm buy some of those sodas for some picnic, but I'm going to buy 100 of them. Not give a lot of people coming to this picnic, not just 10. By 100, what's 100 of those going to do? It's going to move the decimal twice. It'll become $270, right? And what is 100? 10 squared, 10 times 10. You see the 2 power told that to go 2 to the right. You see, really, that's something you already know. You probably just haven't noticed that whenever we multiply by 10 or 100 or 1,000, it moves the decimal, whatever the power really is on the 10. A plain 10 is 10 to the 1. 100 is really 10 squared. It moves the decimal 2 places, makes the price $270, etc. So positive powers move to the right, and likewise, negative powers move to the left. I could show you that real quick. I don't know if you're interested in that much of the why. What if you had a price that was, I don't know, 54? It's a $54, or let's say 540. We're going to buy a whatever, some big thing, $540. But we're going to split the price among 10 people. We're going to divide. We have 10 people all going to divide it among 10 people. What's the price? How much is each person going to pay? $54, like that. What just happened? The decimal moved to the left. What do you mean? Where was the decimal? You know that's 54.00, like that. That's $540. I'm sorry, $540. The decimal is really there. Where did it go? It went one place to the left. See? And what? Okay, yeah, but that's dividing, Mr. Heron. Yeah, I know that's dividing. Dividing is the same thing as multiplying by 10 to the minus 1. It is? Yeah, because 10 to the minus 1, what did we learn about negative powers? It jumps down. That's times 1 over 10, isn't it? And 1, what is this? 1 divided by 10. Divided by 10. See, that's the same thing. So that's a little bit trickier to see that. But my point is negative power multiplying by 10 to a negative power, which is the same as dividing, because negative powers go to the bottom and they're really dividing. So multiplying by a negative power moves it left that many spots. You see, it just does, doesn't it? And multiplying by 10 to a positive power moves it right that many spots, doesn't it? So that's the rule. When they give you 10 to a negative power, you move the decimal left that many spots. They give you 10 to a positive power, you move it right that many spots. There we go.